Hello and welcome to our series of lectures on mathematical method for physics. Today we are going to discuss our first method, that is method of separation of variables. Basically, this method is the most simplest method to solve any ordinary differential equation. In this method, we split all the variables and solve them one by one, and finally we add the solution. The significance of this method is, for example, in electromagnetics, we are solving a problem for potential in 3 dimensions. So it becomes very difficult for us to solve a problem taking all these dimensions in account at a time. So what we do, we split them. For example, if we have x, y, and z direction, and we solve this problem first for x, then y, and finally for z direction. And then we add all the solutions in a single solution and we find the solution. So this method, here in this method, the standard form is, for example, if we have variables in x and y, ax dx plus by dy is equal to 0. So in a given problem, in first step, we will separate one type of variable on one side and other type of variable on other side. Then we will integrate it, and finally we will find the solution. Okay, for better understanding, here we will solve some examples from simple ones to complex ones. In first example, we have x squared dx plus y dy equal to 0. We will solve this problem by using method of separation of variables. According to this method, we will keep this y dy on same side, and we will take this x square dx on the other side, as here we can see. So we will put a minus sign here. As in the next step, we will integrate both sides, and for that purpose, we can simplify them by applying power rule of integration. According to this rule, if we have, when we will solve this integral of y, we will add +1 in the power. Currently it has power 1, so here we will add 1 plus 1, and we will divide this term by the sum, that is 2. Okay, on the other side we will perform same, apply same formula. For x square, it will become x square x2 plus 1 divided by this 2 plus 1. Okay, and here we put some constant of integration. And in this video, I will explain why we put this constant. Okay, to find the solution, we have here y square is equal to minus 2x cube over 3 plus c. We want to find this, simply y. For this, we will take this square root on both sides, and we will obtain y is equal to minus 2 by 3 x cube plus c 1 power 1 by 2. So in this way, we have applied the method of separation of variable, and we have solved this problem. X square dx plus y dy is equal to 0. Okay. In the next example, we are going to solve another problem, that is y prime is equal to y square into x cube. Here again, we will apply the method of separation of variable, and we will solve it. In first step, we can write this prime as dy over dx, y square x cube. Then we will apply the method of separation of variables, and we took this y square on the other side, so it becomes 1 over y square dy, and we take this dx to other side, so here we have x cube dx. Now simply we can integrate both sides. So here we have 1 over y square dy and is equal to integral of x cube dx. Okay, we will apply the same power rule. So we will take 1 over y square upwards. So here we have y power minus 2 plus 1 divided by minus 2 plus 1, that is equal to x cube plus 1 over 3 plus 1. And here I will put the constant of integration c. Okay, when we simplify it further, here we have minus, this minus comes from here, minus 2 plus 1. So I put it here, or 1, and here we will have minus 1. So I put it as 1 upon y is equal to x power 4 by 4 plus this c. So I want to obtain the solution in the form of y. So we will invert it, and we finally obtain y is equal to minus 4 over x power 4 plus c. So this is another example where we are asked to solve this problem. Dy over dx is equal to x square plus 2 over y. To solve it, we will apply the method of separation of variable. So here we can see that we can take this y on the other side, so it will become y dy, and if we take this dx on the other side, here we will have x square plus 2 into dx. Okay, so now we can integrate both sides. So we apply the integration, and here further, when you will put this integration, here we have x square dx and plus 2 integral of 2 dx. So you take this constant out and you will simply obtain x here from here. And in both these cases, you will use the power rule. So here you will have y square by 2. And in this case, you will obtain x cube over 3. In this case, you will have 2x plus this constant of integration. Okay. So here I have y square by 2. I want to simplify it. So I will take this 2 on other side. We will multiply. So it will become 2 by 3x cube plus 4x plus this c. Here I'm not showing 2c because 2c is again a constant. And here we have nominated this c for constant. So I'm putting the c as it is. Okay, finally, I will take the square root on both sides. So I will obtain this y that is equal to 2 by 3 x cube plus 4x plus c under root. Okay. And this is the last example of same fashion where we have y prime is equal to x plus 1 over y power 4 plus 1. To simplify this, we will write it in the form dy over dx is equal to x plus 1 over y power 4 plus 1. So we will separate the variables. So we will take this y power 4 plus 1 to other side and it will be multiplied with this dy. Similarly, we will take this dx to other side and it will become x plus 1 into dx. So the next step is we will apply the integration. So when we will apply this integration here, these are two terms adding, so the integration will be splitted and same process will be occur here. And so further, I put this constant of integration. So you will apply the power rule. So it will give you y power 5 divided by 5 plus this integration of 1 is y is equal to, here you will obtain x square by 2 plus x plus c. Okay. Further, when you will simplify it, you will obtain this y power 5 over 5 plus y is equal to x square by 2 plus x plus c. So you cannot further simplify it because here we have terms in y and x. So that is our solution. So in these all examples, I'm putting this constant of integration. So here I'm giving an example why we put this. For example, you have a function f of x is equal to 2x plus 3. As we know, if we take a function, we differentiate it one time and then we integrate it one time, we should obtain the same function. So just try it. When we do it, here you can see first I took this derivative, so I will obtain 2 as 3 is constant, it will become 0. And again, when I will integrate it, this function d by dx of f of x, that is equal to 2. So I will obtain 2x. So in this process, we have lost this 3, this plus 3. So to balance this, we always put this term c that is known as constant. Okay. Now the other question is how we can find the exact value of this constant. To do so, we need to know the initial values of the problem. Often when you will asked to solve a problem, you will have an equation like this: ax dx plus by dy is equal to 0. And here you will find something given to you. If you don't know, these are basically the initial conditions that actually describe the situation of system at time t equal to 0. For example, if initially the capacitor was fully charged, or it's 0. So how we read it, it is basically value of y, that is y naught, when x is the value of x is equal to x naught. So by applying these initial conditions, we can find the value of constant, and for that purpose now we solve another example. In this example, we have this exponential x dx minus y dy is equal to 0, and our initial condition is y of 0 is equal to 1. That means at x is equal to 0, the value of y is equal to 1. Okay, so we will start this problem by applying method of separation of variable. We have separated this into x and y, so we took this y dy on the other side, and in next step, as you know, we will perform the integration. So when we perform the integration, we obtain this exponential power x plus c, and here again we applied the power rule, so that is y square over 2. So we want to find a solution in the term of y, so we just arranged it in this fashion: y square by 2 is equal to exponential power x plus c. So I want to obtain this y, so I will take this 2 on the other side, so it will become 2 exponential power x into 2c. But this 2c actually again is a constant, so I will take it as c. But at first, I'm applying these initial conditions to find this value of c, that is at x is equal to 0, y is equal to 1. So when you will put these values in this equation, so here you will obtain 1 square is equal to 2 into exponential power 0 plus this constant. So just simplify it. So you will obtain this value that is equal to, so in this way we have found this the value of constant, that is equal to c is equal to -1. We will put this value back here in this equation, and this becomes y square is equal to 2 times exponential power x minus 1. I want to find the value of y, take the square root on both sides, and you will obtain y is equal to under root 2 times exponential power x minus 1. So that is the solution. So based on these initial conditions, we can solve another example here, that is x times cos x dx plus 1 in 1 minus 6y power 5 dy is equal to 0. And our initial condition in this case are y of pi is equal to 0. That means when x is equal to pi, y is equal to 0. So in the first step, we will apply the method of separation of variable. So we split these terms into x and this term on y other side. And here we have this plus sign, so we will put this minus here. Okay, so here the integration is not straightforward as we had in our previous cases. Here we have the term x into cos of x. To integrate this, we need to use integration by parts. When we will apply this integration by parts, we will obtain this solution x sine x plus cos x. And if we want to verify, we have very straightforward method. We use this relation I late. Here I stands for inverse trigonometry, for example, sine inverse x or cos inverse x. L stands for logarithmic functions. A is algebraic for algebraic function, for example, x square or x cube. T stands for trigonometric functions that are again sine x or cos x. And finally, we have E. It stands for exponential functions, for example, x e power x or e power 2x. So this is the order how we select the first function and the second function. So in our case, I'm calling the first function u, second function v. So u is equal to x and v is equal to cos x. Okay, further, if you want to solve it, I'm doing it for you. It is u is equal to x, v is equal to cos x. Put it here, and integration, but the formula for integration by parts is uv integral of with respect to dx is equal to u as it is times the integral of v times dx minus the integral into derivative of u with respect to x and integral of v whole dx. So dear students, we will use the same relation in Laplace transform at many occasions, so we can remember it. And in the next step, this u is replaced with x, and integral of this cos x is sin x, and this minus sign comes from here, and derivative of x with respect to x is 1, so I put it here, and again the integral of v is sin x. So we have this term time the integral of sin x with this minus sign outside. So as we know, the integral of sin x is equal to minus cos x, so put it here, and simply we have minus cos x, and this minus will become plus cos x. So we have simplified it. The next integral is this minus 1 dy, it will simply give you minus y, and finally we have this integral 6 multiplied by y power 5 dy. We will, when you will apply the power rule, you will obtain this 6 times y power 5 plus 1 divided by 5 plus 1. So this 6 will be cancelled with this 6, and you will obtain this y power 6. So putting all these values of these three integrals, we will obtain x times sin x plus cos x plus c, that is equal to minus y plus y power 6. So here again, I have this constant of integration c. To find its value, I will go back to my initial conditions. At x is equal to pi, we have y is equal to 0. So if we put this, we have this pi times sin pi plus cos pi plus c is equal to 0. When you will simplify it, you will obtain that sin pi is equal to 0, cos pi is equal to minus 1. So here we have minus 1 plus c is equal to 0, and that will give you c is equal to 1. So now we have found the value of this constant c, that is 1. So when in the next step you put these values, so the equation will be arranged in this order. So that is our solution, as we cannot simplify further this equation. Thank you very much for your time and attention.